Scholars, we've been learning lots of strategies for addition, but today we're going to focus on one that is going to help us add lots of big numbers very quickly. We are going to be working with the chip model strategy. So a lot of you are probably already going to remember this from when we were working with making tens and using those to make hundreds. Today we're going to see how a chip model works when we have bigger numbers, when we are bundling both tens and hundreds. So these are our steps for our chip model strategy. First, we write the problem in vertical form. After that, we draw a chip model. Since we are adding, we will show both numbers. Then we're going to add the ones, and we'll look and see if we need to bundle a 10. After that, we'll add the tens, and we'll see if we need to bundle 100. And then finally, we're going to check carefully to make sure that our drawing and our vertical form match. All right, let's look at Miss Burtis's first example. So I see 303 plus 37. I know that my first step is to write in vertical form. So I'm going to do that right now. 303 plus 37. All right, I have vertical form. Now step 2 is to draw both numbers on my chip model. So let's see, 300s. Making them in my nice neat rows, and 3 ones. Then I'm going to leave some space so I can see that this is a different number, and I have 37. Let's see, 3 tens, and 7 ones. Making them in 5 groups so I can see them. All right, let's go back to my steps and see how I'm doing. Let's see, 1, write the problem in vertical form, check. 2, draw a chip model showing both numbers, check. All right, so now I'm on to step 3 and 4, which say add the ones and add the tens. Let's look back at our problem. Let's see, I see 3 and I see 7. Now I know that 3 plus 7 equals 10. So if I have 10 ones, I need to move those. So 10 ones becomes 1 10. I'm going to bundle that and move it to my tens. And I'm going to show that on my vertical form because I have 0 tens left in the ones place because I made a 10. So 0 in the ones and that 10 goes right here. Now let's see, I have 3 tens plus my new 10. So 3 plus 1 equals 4. And then finally I have 3 plus 0. So 3 plus 0 equals 3. Let's look back at my steps. Let's see, I've got 1, 2, 3, and 4. So now my last step is make sure your drawing and vertical form match. Okay, so let's see. My answer should match my drawing. So I have 0 ones left in my ones place. Okay, that looks good. I have 4 tens in my tens place, so that looks good. And I have 3 hundreds in my hundreds place, just like my drawing. Check. All right, let's work on another one together using what we know about our chip model to add when we have hundreds and tens. So 211 plus 95. Who can tell me what my first step should be? I'm going to draw it in vertical form. 211 plus 95. All right, that was step 1. What is step 2? Step 2 is to draw both numbers using a chip model. So 2 hundreds, 1 10, 1 1, 9 tens, and 5 ones. All right, now we need to first add our ones and then add our tens. We have 1, 1 plus 5 ones. 1, 1 plus 5 ones equals? It equals 6. Did I need to bundle my ones there? No, I didn't because I didn't have to make a 10. I had 1 plus 5. That's not enough to make a 10. Now let's add our tens. How many do we see on Miss Burtis's chip model? I have 1 plus 9, and I know that 1 plus 9 equals 10. So that means I need to bundle and move these 10s. So I have 1 plus 9 equals 10, and so now we have 100. So 0 goes in my tens place, and this 100 goes right here. And now finally I have 2 hundreds plus 100. 2 plus 1 equals 3. So now I need to check and make sure my drawing matches. Let's see, I have 6 ones in my ones place, and that's what I have in my vertical form. I have 0 tens left in my tens place. That's what my vertical form says. And then I have 3 hundreds and 3 hundreds in my hundreds place. So my drawing matches my problem. Scholars, I'd like you to try this one on a piece of paper in front of you. We're going to go over this answer in about a minute, so go ahead and take this time to figure out this answer on your own. Don't forget your vertical form and your chip model.